No, we are recording now, I think. So I will not be able to go into great detail, but I'd like to give you a flavor of all the different aspects and facets that relate to volcanoes and resources. So what I will talk about is metals and ores, and as Francis said, there will be more detail this afternoon with Erik Jonsson, who's really a mining specialist. And then I will talk a little bit about gemstones and also about, let me just click something else here, I'll see that. Great. Then I'll talk a little bit about sulfur, which is quite important actually, and it's going to become even more important because currently we're sourcing sulfur as a byproduct from fossil fuel production, which hopefully will not be an issue in the future, but then we need new sulfur sources. So building materials is of course very, very important, and I'll talk about that a little bit. Abrasion materials for industry, and I'll have a short word about geothermal power, and also about producing salts in terms of resources like lithium, but also in terms of food production. And then we'll talk a little bit about food, drink, and I'm going to have a short excursion into cosmetics. Then I'll touch on geotourism and a little bit on artistic inspiration and also religious inspiration. And that leads us on to volcanoes and culture. And then if we have time, I will say a short word about volcanoes and climate. And some people think volcanoes could play a role in climate change, and I'll try to touch on that as well. So let's get going. Well, metals is my first major point here. And well, some of you might or might not know, metals are something our industry thrives on. Our modern high-tech world is built to a large degree on metals. And what most people don't fully realize, at least in the general public, is that most metal deposits are directly or indirectly linked to volcanoes. And volcanoes often concentrate economically relevant mineral deposits. Most of the gold we have is ultimately volcanic, silver as well, lead, copper, diamonds, etc. And in fact, Sweden is quite famous for its iron production. It is the #1 producer of iron ore in Europe, and most of this is volcanic in origin. The big mines in the north of Sweden, the Kiruna and Malmberget mines, they are in an old volcanic terrain. Now the volcanoes are long eroded, but the rocks that have concentrated the metals underneath the volcano, they are there and exposed now. And that is what we are harvesting right now. So without some ancient volcanoes, Sweden would not have these concentrations of iron, copper, silver, and other important metals. So I just mentioned iron being the key metal that is produced here in Sweden. Copper has also been very important. There's, maybe you know, the Falun mine. It's a World Heritage Site now, and this produced so much copper that most of the world's copper for some time, a few hundred years ago at least, was actually produced there. And also very close to here, there's Sala silver mine. Silver has been a huge financial boost for Sweden over many hundred years, and much of Sweden's well, expansion politics a few hundred years back was financed with silver from these mines. And the ore that we are getting there is usually connected directly or indirectly to volcanic activity, and we can extract the metal from there, and then we can produce articles there. And we can either sell them for economic profit, or we can make things from that. And Sweden's high-tech industry is to a large degree based on the metal production that's happening here in the country. So let me just kind of make some points. If you drive over a big bridge, then usually there is iron in there, a lot of iron, and we make steel from iron. Steel is iron plus carbon with a small percentage of carbon added, and that makes the iron more flexible. It's getting bendy, and that's very good for making buildings, bridges, skyscrapers, etc. So copper is very important as an electric conductor, and these are two base metals that have been mined in Sweden for many hundred years, and there's high concentrations of those, and it makes Sweden the most metal-rich country in Europe. And let me also point out, besides copper, there is an image of native copper in the top right here of my screen, and there's a big open pit mine in the north of Sweden on the upper left here. And copper can be associated with silver and gold. This often happens in volcanoes, but they get concentrated by fluids. And in the bottom left, there's an image of a copper, silver, gold native aggregate. Quite spectacular, actually. And if these things are then transported by erosion into rivers, then you get what is shown on television, the placer deposits, the deposits in rivers where gold nuggets are found, but ultimately they actually come from volcanoes that are eroded. So copper is crucial for modern technology. It's a super electric conductor, and without copper, we wouldn't live in the society we live in. And predictions are that we will need a lot of copper in the future, because if we want to allow living standards to rise on a global level, we need to provide a lot of electronic goods to many parts of the world, and copper is the element that is required for that. Despite copper being a very common metal, we will still need huge amounts of it in the future. So we're likely going to have insufficient amounts of copper on the continents, and we might need to go submarine or even into space to get more of it. So silver, let me just grab my coffee 1 second. Silver is also often concentrated in volcanoes, particularly in South American volcanoes. This is where the Spanish Empire was so keen to keep the holdings in South America. It was financing the empire with silver. There was whole treasure fleets coming from South America. And silver is chemically rather inert, not quite as much as gold, but it's therefore a very valuable metal. And some people also believe it's got healing properties. And silver is something that was financing global trade and commerce for many hundred years. And there will be no shortage in terms of importance of silver in the future. Gold. Gold is the most inert of the metals that we have out there. And this is why gold has been used as a standard for our currencies. And gold is also very nice to look at. And gold is actually very rare, surprisingly rare. This is also why it's so expensive. So it's very soft, as you probably know. You can actually put your teeth into it and it'll make a dent. And therefore, you can test the quality of gold very easily. And this has made gold one of the main currency metals out there. And whenever economy is going downhill, people invest into gold. And nowadays, I understand that China is buying loads of gold. Most gold in the world that has been produced is actually located in China these days. And just to give you a flavor, if you take all the gold that was ever mined and you put it into one cube, then that's kind of the size of this cube. It's just over 20 meters side length. And there's a tiny little black human figure next to it. So gold is surprisingly rare. And therefore, it is rather useful as a currency. And also, if you want to have safety, financial safety, then investing into gold is something that humans have been done for a long time. I mentioned it, we might need to kind of explore submarine resources in the future. And as you probably know, 80% of volcanoes on our planet are actually underwater. So most of the submarine deposits are linked to volcanoes, and we will need a lot of manganese, cobalt, and magnesium in the future to electrify the traffic. We need these elements in batteries, and therefore we have huge kind of potential to harvest these elements, but we will have to go to submarine resources, which is technically very challenging. And it's also, of course, a big issue for marine ecosystems. And this is something that we need to consider very, very carefully. But in principle, there's loads of material there that we can harvest if we start to find ways of doing it the right way, I would personally argue here. So, and there's also sulfites. Sulfites is, for example, copper and iron sulfites. They can concentrate along mid-ocean ridges. This is also volcanic features in the sub-oceanic environment. And there we have huge amounts of reserves that we have not tapped into so far. So there is more metals. If we need more, we can get them, but they will come at probably quite some high technological and ecological price. So here's an image of a manganese crust. This is precipitate out of the ocean water, and it forms on, in this case, an oceanic rock, and the rock is kind of orangey in color, and the manganese crust is dark. The manganese in these crusts usually comes from submarine volcanoes. The manganese dissolves in water and precipitates elsewhere. And if you have old volcanoes, for example, say Cretaceous ones that are 150 million years old, you find that the manganese crusts that have accumulated can be quite thick, many centimeters. And these contain a lot of rare earth elements, but also cobalt and manganese. And this is what we need for our energy transition and for electrifying our traffic, and also for IT technology. So there is a lot of it, but we must be aware that these crusts accumulate at a rate of about 1 millimeter per million year. So they will not regrow very rapidly. Once we have harvested a lot of them, it's going to take some time. However, there's quite a lot because the ocean surface is vast compared to the continental land surface. So there is a lot of this material available if we want to harvest it. So let me move on. I'd like to talk a little bit about gemstones now. And well, here's some nice images. This is the British crown jewels, and also some other crown jewels. Yeah, well, you see there's diamonds and rubies and other kind of fancy stones, and many of them relate to volcanoes in one form or another, so I should stress that as well. And diamonds, for instance, they come from the earth mantle, and they have been large deposits have been quarried in South America, and there they come up in these diatremes. We call them kimberlite after the place there, Kimberley. And there we have large concentrations of diamonds. And diamond is the hardest mineral that we have, so it's also got some industrial application. It's not just beautiful. And some of these diamonds can be very, very large. And well, people say that they bring bad luck for those who wear them, but that's a different thing. That's a belief, I guess, rather than a reality. Some of these beautiful diamonds, they are traded for, well, huge amounts of money. And De Beers, one of the big companies there, they are currently struggling a little because more and more diamonds are found offshore and in other parts of the world, and small independent upstart companies are now throwing a lot of diamond on the market, and this might cause some economic problems for De Beers in the long run, but I guess we'll see. And here's a few more. Here's tourmaline. Tourmaline is a boron mineral, and it also connects to volcanoes. In late stage evolution of volcanoes, you sometimes get concentrations of elements like boron and lithium, and we can mine them, and this is very important for fertilizers. This is also important for making batteries. Lithium is very important for making batteries, and electrification of air as well as regular traffic will require huge amounts of lithium, much more than we are quarrying right now. So we will probably have to go and mine more of these volcanic rocks if we want to electrify our traffic. Then there's fluorite. Fluorite is a very interesting mineral. It's very important for optics, but actually if you are brushing your teeth with a toothpaste that contains fluor, then you have just touched a volcano today, because most of it comes from late stage rocks that are associated with subvolcanic environments, and fluorite is the main source for fluor. Another one that I find personally very appealing, that is obsidian. Obsidian is a volcanic glass, and in fact, it's been used since early human days as a tool. And one of the first tools that we have preserved is actually volcanic glass, because it splinters in a very strange way. It makes these really sharp edges. Many crystals have predefined breakage cleavages, i.e. lines where they break, but glass doesn't. It makes these really sharp edges. and arrowheads and knives have traditionally been made in traditional societies with obsidian, and it was traded already 5,000 years ago. There's good evidence that these obsidian flakes and shards were traded all over Europe, and this was one of the key tools. And here, for example, we have obsidian tools from Turkey, and this goes back to the 5th millennium BC. And then there's other ones from the Mayans on the right-hand side. So different cultures and different parts of the planet have exploited these a long time ago already, and not enough. It's still used today. There's apparently some people who like to still use obsidian as blades today. You can use it for cosmetical purposes, but in fact, it makes super clean cuts. And a lot of surgeons prefer obsidian over steel blades because they are a lot sharper, and they make these cuts that are so beautifully clean that healing is a lot easier. So this is still used in surgical instruments today. So from that point of view, these volcanic rocks have a lot of very useful purposes, even in today's society. And of course, it's used as a gemstone in jewelry as well. And some people say it gives you volcanic powers. I don't know about that, but it's certainly nice to look at. It's got a dark shine, and this makes them very attractive for jewelry. Now, I will not talk lots about that, but white gold porcelain is something that has been around for quite some time, initially developed by the Chinese. It's a technique where you use mainly feldspar. Feldspar is a rock that occurs typically in granites and derivatives of granites, and that is a late-stage magmatic rock. It happens under volcanoes, it forms under volcanoes. And here's a big feldspar in the lower left. And if you manage to process this in the right way, you get a clay from that, and you can actually make porcelain from that. And it was a big, big challenge to get the technology imported to Europe. Eventually, several manufacturers in Europe managed to actually get it going here, and this reduced the dependency on Chinese imports. And today we're still quite dependent on, for example, rare earth element imports from China. So some things don't change. Maybe the materials change, but the concepts don't. So white gold has been very, very important because it is much more hygienic. You can recycle it. Wooden plates are not very hygienic. And so also in Sweden in particular, the introduction of the porcelain stoves has been a game changer for the way we build and live. So this is very, very important. And it's coming principally from volcanic resources. So sulfur. Sulfur is very important, and as I said, for the last 100 years, we are getting sulfur as a byproduct from fossil fuel production. Once we are going off fossil fuels, then we will have to go back to quarrying sulfur from rock. And most of the sulfur is originally volcanic. It can be deposited in sediments as well. 60% of the sulfur in our air is originally volcanic. And here's some images from fieldwork in Indonesia. And as Francis said, we've been doing work together for quite some time. And here are some sulfur deposits and a sulfur mine on the right-hand side in Java in Indonesia. And here, sulfur is deposited from hot gases. And the lake you see on the top right is actually an acid lake. You don't want to put your finger in there. It's really kind of highly acidic. And these hot gases that come out, they crystallize, they precipitate sulfur when the gas is cool. And sometimes you even get these little liquid sulfur lava flows. And once they cool, they go yellow. When they're liquid, they are orange. And sulfur burns really, really well. And it's also good for disinfection. So people have been quarrying sulfur for a long, long time in these places. And here at the very bottom right, you see one of the miners carrying something like 50 kilos of sulfur out of the volcanic crater. There's no way you can do this with machinery, so the work conditions are quite tough, but There is no other way of getting this out, so this is manual labor for many parts, and this will likely have to be reinvigorated once we are going off fossil fuel production and therefore also off sulfur production. So here's a few more impressions from Indonesia. This is in East Java. This is the Kava Ijen sulfur mine, and people are channeling the fumes, the fumaroles, the fumarole gases into these pipes, and there they condense, and then they make these sulfur liquids, the little sulfur lavas, and they come out, and then you can actually break them once they're cool, and then that's what's used for dynamite production, for matches, and for things like that. So here's a few impressions. Well, most of the dynamite that we produce still has volcanic sulfur in it, and gunpowder, as you might know, is charcoal, potassium nitrate, plus sulfur. And if you think of Sweden's history, the time where Sweden was expanding and participating in a lot of militant conflicts on the continent, most of the sulfur actually came from Iceland. And it was used for gunpowder, and today we use it for dynamite. Mr. Nobel, who, the inventor of the Nobel Prize, he actually got rich with dynamite, and for that you need sulfur. And there are some matches up there. They have sulfur from usually volcanoes, at least in the old day, and also for disinfection. There is, particularly in China, it's a very popular product. You can buy sulfur soap. But when you think of disinfecting barrels for winemaking, there's still sulfur used for that as well. So here's a few impressions of old sulfur mines that fell out of action in the high Andes, in this case in Chile, which I visited a short while ago. And once sulfur was harvested from the oil industry as a byproduct, as I said, these mines weren't viable, but they will likely have to be reopened in years to come once we need new sources of sulfur. So here's one of the highest mines. It's a high altitude mine. This is above 5,000 meters of altitude. You can't live there anymore. You can only be there for a few hours, and then maybe a day, and then you better go down again. And this was quarried for sulfur during the war between Chile and Bolivia, when they were desperate for sulfur and making gunpowder. And these places are likely going to be reopened in one form or another. So let me touch on building materials for a little while now. And well, I guess one of the first building materials that we employed in terms of volcanic resources was actually digging caves. And here is some of the really world famous caves in Cappadocia in Turkey. And this is a fluffy volcanic rock. It's a tuff, and that means it's not very densely consolidated. And you can dig it very, very easily. And often there's even bubbles of gas or fragments from other rock that's in there that fall out. And then you have a start of a natural cave, and then often people continue digging in, making entire cities in volcanic rock. And if you think of early human development, these are beautiful shelters, and they're high up. You can protect yourself rather easily from wild beasts and maybe other sort of predators, and you can store resources there, and it's easy to enlarge. So you will have to bring your food there, but overall these have been very kind of safe spaces for humans right from an early day. And here's a few more impressions from the Canary Islands this time. The little cave on the left is called the King's Cave. One of the local chieftains might have lived there. And on the right-hand side, there is a very famous place. It's a UNESCO site now, which was probably used as a grain store. And the small human figure there on the lower left, that's actually Francis Deegan, serving as a scale here. And there's all sorts of legends connected to these places. Many of these legends are probably not entirely true. We're pretty confident now that these were grain stores. They were high up in the mountains, they were dry, and they were easily protected. So they that makes for a good grain store. So your harvest can be stored there for a long time. And this makes you independent of weather to a certain degree. So this is a huge resource. If you can actually survive 1 or 2 bad years because you have grain reserves that last, that's a big advantage for society and civilization. So volcanoes were quite a contributor to that. So here's a few more of those caves in the Canary Islands, and today many of them are actually recycled as restaurants. So here on the right-hand side, you see the entrance to a little cave restaurant. It's quite a large one. I've been there once and had a meal there and during field work, and it's very popular as well because it's cool inside but it's hot on the outside. So they're still in use today, some of them at least. I should also point out that volcanic rock is very durable, and people argue that if our society was to collapse, certain documents would survive, and in particular, things that are written in stone. They have a much, much longer shelf life than our way of storage because well, we need electricity and CDs and memory disks. They don't have a long shelf life, really. But petroglyphs have, and here again from the Canary Islands, there's some volcanic stone in which local people have left some messages. And you see some complicated, petroglyphs. It's very hard to decipher them today and their meaning. There is similar ones found in Northern Africa. This one here is in the Canary Islands. And we might not be entirely sure what the meaning is, but we actually have the signal. And on the left-hand side, there's an image of an upstanding rock, the light-colored rock. And this was actually one of these places where the Aboriginal population left some petroglyphs. There was an eruption in 1971, in this case on the island of La Palma, and the lava flow, the dark rock, was flowing around this. It was about to cover it, but thankfully the rocks survived the Guanche messages. Guanche was the Aboriginal people there. They are still there. Maybe future eruptions will cover it, but the 1971 eruption did not cover it. But as you see at the lower end of the image, there is already agriculture on the fresh lava, because I'll cover this later. Lava is also very, very good for growing things. It's very fertile for agriculture, but we'll touch on this in a few minutes. So another way of using volcanic rock has been for a long time by putting things on top of it. Volcanic rock is often very hard and it weathers very slowly. So if you have a volcanic neck, a plug or an intrusion in a soft sedimentary rock, then the millions of years of erosion might take the soft sediment away and might leave upstanding masses of volcanic rock. And here we have Mont Saint-Michel in northern France, and this is actually on a volcanic intrusion. And at high tide, it's isolated, and at low tide, you can actually go over. I think now you can drive there, but traditionally or originally, this was an isolated place, making it a very safe space if you want to retreat. And also, if you imagine some Vikings want to kind of, plunder this, then it's going to be quite challenging for them to scale up the hill, and it's easily defended. So this was something that people have been exploiting for many, many hundreds, if not thousands of years. And here we see a similar phenomenon. This is Edinburgh Castle in Scotland. And we have a large castle sitting on a volcanic rock. And this makes it very, very easy to defend. And it's therefore a safe space that people have been exploiting. And this is similar for Stirling Castle. You might or might not know, but it's played a very significant role in Scottish history. This is where many battles were fought at the base of it, because it was always that armies tried to conquer the castle and had to besiege it, but it was almost, it was indefeatable. So, and therefore many things happened at the base of it, but the castle itself was rarely kind of occupied or was rarely conquered by enemies, and many of the important activities like Robert the Bruce and William Wallace, etc. They fought at the foot of this castle. And therefore, these places had magnificent influence on history, on human history. So this is something important to realize. And this is going through countries and across cultures. Here is an example from Austria, the Regensburg. And this is also sitting on a big volcanic neck. And it makes it very, very easily defendable. And well, the other side is, of course, you have to bring your supplies up there. But once you manage to do so, you created a rather safe space. Now, volcanic rocks have been used as building stones since ancient days. And there's two extreme types. We have basaltic rocks, and they are very solid. They are the dark ones. And we have the more fluffy, light, pumiceous rocks. And they differ in chemistry and properties. And the dark basaltic rocks, they're very massive, very solid stones. So if you build walls from that, they will likely last. If you want to have a breathable space, if you want to have a house that is good for insulation, then the pumiceous rock is better. So here on the left, in the lower part, you see blocks of basalt used ultimately for building. And then you have a little monument here in the top left, which is made from a tuff that was erupted somewhere in the border area between France and Germany. It's easily workable. This is also the material into which caves are dug very easily. On the right-hand side, there is a church in Clermont in the central France in the Auvergne region, which had experienced recent volcanism. And there, many of these buildings are made of basalt. You see the dark color of it, and it makes them very solid, very sturdy. And this is something that people have been using for a long, long time. Let me give you a flavor here. This is from the Canary Islands, which is a volcanic archipelago. And prior to the European conquest, the Aboriginal population was using volcanic stones, and also some of the local limestone to actually cement some of these stones together. But the cement idea was poorly developed. It wasn't very advanced at that point in these cultures. But the building of tumuli, i.e. kind of grave hills, and also simple housing was made with volcanic stone. And here you see kind of simple huts in the lower left that were then covered with palm leaves and things like that. So they were providing simple shelter from the winds and the elements. And they were often located close to the coast so that you could do fishing. And particularly in tidal areas, you often have little ponds, and then fish would get caught there. So it was easy pickings. And this provided quite a nice living, I believe, a simple but very nice living for the local populations prior to the Europeans arriving there. Now here, the Romans, they were pushing this a little further, and here we have some example of a Roman building, and the Romans used volcanic stone, but they also advanced the idea of cement, and they were using aggregates of limestone and volcanic tuff, the pozzolana cement, and with that they were able to really put rocks next to each other and have them stick to each other. And if you use the fluffy pumiceous type rock, as it's seen here in the top right hand, then you could actually build large buildings, and you could build very, very high. At the same time, you could make them quite sturdy. And Italy is a country that suffers from earthquakes, as we all know, and often the way these rocks break in an earthquake is very important. And volcanic rock, particularly these volcanic rocks, have proved quite okay, because you can also fix them afterwards with a cement again. And therefore, some of these ancient buildings are quite earthquake resistant. They're not earthquake proof and in the common sense as we see it today, but they can survive quite some earthquakes, and they can be fixed again rather swiftly and easily. So the Romans were really pioneering these techniques, using a lot of volcanic rocks. And well, Italy has a lot of volcanic rocks, so they were close to the source as well. They exploited the local resources in this context. So let's move beyond Europe and beyond the Romans. Here's some examples from Indonesia. Again, this is on Java, and in the lower right-hand side, we have one of the big aggressive volcanoes in Indonesia. This is Merapi volcano. It's, well, people call it a killer volcano. It has killed probably something like 5,000 people in the last few hundred years alone. But it's also a very rich area. It's called the Garden of Indonesia because the soil is very fertile, and we'll come back to this shortly. And it produces a lot of lava rock, and people have worked with this. One of the largest Buddhist temple in Southeast Asia, in the world, in fact, is made of volcanic rock. It's Borobudur. And very close by, there's a Hindu temple. It's only about 200 years younger than the Buddhist temple. It's called Prambanan. And in my support material, I have a few short videos on this to give you an impression. And so local people were using this material. It's got some pore spaces, so it's not completely massive, meaning it's reasonably easy to work at the same time as it's very solid. So many of the building stones we produce today are modeled on volcanic rocks. We're using the volcanic rocks as a good example for that. And here, these temples were built over 1,000 years ago. People had understood these concepts already back then. And I quickly want to jump back to a little bit of a younger period in history. This is now the Canary Islands after the Spanish conquest. And here we are on Tenerife now. And I visited some quarry there a few years ago. And people are quarrying some of these volcanic rocks there. And this is the Arico Church. It's one of the protected little churches that has a colonial style. And this is what the Spanish Empire kind of propagated also later into South America. And this is made of local volcanic rock. And Francis and myself, we currently have a little project trying to understand why this particular rock was so attractive for building measures. And our preliminary data suggests that it has a lot of pore spaces. And that means it's easy to work. It's easy to transport, it's light, but at the same time, it's really, really strong. It's very hard to break it. And this means that it's a very, very good building material. With the right tools, you can work it rather easily. So once the Spanish introduced metal tools, this was something they could work, which the local pre-Spanish population was not able to do. So here, with bringing different components together like metal tools and volcanic rock, suddenly some new avenues opened up, allowing construction of these, in my view, rather nice to look at little churches that have actually withstood the test of time, because Tenerife also has earthquakes, and this little church has not really been damaged in any of the earthquakes, surprisingly. So here's a few more examples, and this is again from central France now, and from medieval kind of castles up to cathedrals of the Renaissance period and later. Many of them were actually made of local volcanic stone, and that's a very good building material. Not to mention millstones. This is also something that is in fact often made from volcanic rock. Many of the millstones here in Scandinavia, they actually come from continental France or Germany, where they were imported. Volcanic rock from these areas was imported because the millstone has, if it has volcanic origin, it has these little tiny bubbles, these vesicles, and that means it sharpens itself when it grinds itself against the hard material. So you don't actually have to resharpen it. This is a beautiful little aspect of it. So by grinding it down, you are actually resharpening it all the time. One of the downsides was that Vikings had notoriously bad teeth. And this is actually because of the tiny volcanic particles in some of these, well, in some of the products. So if you take a corn and you grind it down, then there's tiny volcanic particles in there, and this also grinds against your teeth. And we'll talk a little bit about abrasion very soon, and volcanic material is very good as an abrasive as well. So, but before we go there, I'd like to say a few words about aggregates. We use huge amounts of aggregates. Europeans use something like 450 tons over our lifetime of aggregate material. This includes aggregates in roads, in buildings, and aggregates is something that we are consuming at an enormous rate. And many of these aggregates come from volcanic rock, because volcanic rock is very strong. If you go on a trip with the rail in a train, then you are usually riding over volcanic rocks because the aggregates are so sturdy. And here on the left-hand side, I'm showing you two aggregate quarries in Indonesia again. This is at Merapi volcano once more. And some of these very recent deposits there, they are unconsolidated. They're very fluffy, made of millions, zillions of tiny particles, and they're quarried there as aggregates for building, but also as fertilizer for the soils in the area. And there's a positive side effect if you quarry close to the volcano. If there's new eruptions of the volcano, then these areas that have been quarried will become sediment traps. This is why they quarry perpendicular to the axis of the valley, so that any lava or more pyroclastic material will actually get trapped in these areas, in these little valleys they have dug across the main valley. And this has a hazard aspect as well, so it would slow down any lava or any pyroclastic flow coming from the volcano. So here, aggregate quarrying and civil protection are going hand in hand, and the aggregates are used at enormous rates, as I said. But we also use volcanic stone for cladding, i.e. as decorative or protective surface materials. And the lower left picture here is from Copenhagen Airport a few years ago. I was traveling through Copenhagen and I was fascinated by the crystals. On the right-hand side, in the center of the image, you can see a nice big crystal. And then on the lower right-hand side, the crystal is even more detailed. So you can see growth rings of the crystal. We often like to think we can read these growth rings of crystals like botanists can read tree rings, so it tells you something about how often the volcano was recharged with magma and things like that. So I was very fascinated by this, and these rocks still preserve a record of the volcanic history of these stones. So here's a few examples. You can have them in all sorts of varieties depending on which source rock you use. You can have dark ones and red ones and whitish ones. And these are very, very good because they don't react with water. If you use marble surfaces, they are very nice to look at, but marble is made of calcium carbonate and it reacts with water. So if you have marble, then after many tens or potentially hundreds of years, marble will decay. So cathedrals made of marble have a shorter lifespan than cathedrals made of volcanic rock, because these sedimentary limestone type rocks, they react with water, while volcanic rock is usually more sturdy in that sense. So I promised you I'll talk a little bit about abrasion materials, and one of the key abrasive materials that has been used for thousands of years is pumice rock. And it's used today in cosmetic applications as well as in industrial applications. And usually pumice is highly porous. It's got 70% of bubbles, gas bubbles, and it often has high silica, making it very solid, and it's often also glass rich. So it has micro cutting edges, if you will, and this is very good as an abrasive. And here's some cosmetical applications. And if you have whitening toothpaste, very frequently there's micro powder of pumice in there. And this actually makes your teeth white because you are grinding off the dark kind of coatings that your teeth might accumulate from coffee or tea. And then the pumice will be able to take that off. And here on the right-hand side, you have some cosmetic product. And if you kind of think about it, yeah, there is actually a tiny bit of volcano in many of these products. So here's a few more of these examples. And if you look very carefully on the small print in the top left, it says with ground pumice stone. And on the top right, it also says with pumice, it's a pumice food scrub, etc., etc. So all of these products have actually original volcanic stone in them, but in a finely ground up variety. So when I was young, there was a new fashion coming up. Prior to this, there was only kind of dark blue jeans that you could buy, but then worn out blue jeans became really fashionable, and they were called stone washed jeans, because what really happened is they were tumbled in a big container together with pumice stone, and this was giving them a worn look. So stone washed jeans are actually made from volcanic rock, and this I thought was a nice twist. And yeah, if you want your jeans to kind of not look entirely new, then likely pumice, volcanic rock has been involved. So a few words about geothermal power, and I'll see on the watch we're going to have a short break in about 5 minutes or so, or 6 minutes, but let's cover the geothermal aspect very briefly. I don't want to say very much about it, but geothermal power in volcanic regions is something that we're getting better at. We haven't really learned, we have only learned to harvest this over the last 50 years or so. And it's relatively cheap and it's relatively clean once you can manage to handle it properly. In the top right, there's Wairaki power plant in New Zealand. And there we are harvesting the hot steam that comes up, and we can channel it, and we can either make electricity from it, or we can heat greenhouses or districts, housing districts with it. And if you've ever been to Iceland, in the old town in Iceland, they still use some of the very early systems. If you kind of open the shower there, it starts to smell of sulfur, because it's usually hot water from volcanoes that is used for that. And nowadays it's used all over the world, wherever there's volcanic activities. Here is an example from the Philippines, where volcanic heat is channeled into these pipe systems and then into electric generators to produce electricity. The steam and the volcanic gases would escape into the atmosphere anyway. So we are really harvesting the energy that comes with it. And let me go back here. Sometimes the pipes in the lower right-hand side, they clog up with time. And in fact, this is something very useful, because there's a lot of interesting minerals accumulating there. One of the most important ones is silver. So people can actually harvest silver from these pipes as well. So here's an example from Indonesia now. This is in West Java, one of the main power plants there, which supplies energy to the capital there in Yogyakarta. And the Indonesian government is very keen to build more of these power plants, because that reduces their dependency on fossil fuels dramatically. Here is Iceland, and Iceland is not only using it for district heating and for electricity, but actually also for touristic purposes. If you've ever been to the Blue Lagoon, one of these nice kind of hot pools, this is actually the leftover waters. It's a byproduct from the geothermal energy production. And here is a little graph where you see how it's used. 40% is actually used for electricity generation, and then smaller proportions are used for hot pools, for snow melting, fish farming, and for greenhouses. And indeed, a large proportion, 43% on this chart, is used for heating. So this is where I kind of like to move into salt production very briefly before our break. And this is the Atacama Desert in northern Chile. And you see the volcanoes here in the background, and you see some of these salt lakes. And the salts are actually elements that are washed out of volcanic rock. And once the water evaporates, it produces these huge salt lakes. And they have one of the highest concentrations of lithium, which we need for battery production. So this is one of the key targets for harvesting lithium in future decades in order to allow us to electrify traffic. And unfortunately, it's very beautiful landscapes. And we're going to be very challenged to find compromises between harvesting the elements from there and, you know, thinking about our green technologies. So, and preserving the ecosystem at the same time. But this is something we can discuss a little more when we discuss the future of mining a little bit later in the week. So here's just a few impressions of these salt crusts. And as I said, the elements from there are ultimately from the volcanoes. And here is a big salar, and this is currently quarried. You see the kind of deposits there in the top left and the top right. Most of it is in fact actually going to China and Japan. They are paying huge amounts of money to buy up these salts because the electrification of their industry is something they're pushing really, really hard. And here's some plant where it's harvested, these salts, and we are only exploiting a very tiny percentage of these salars, of these salt lakes at the moment. And the governments of Bolivia and Chile are very keen to sell concessions for larger exploitations. But of course, many of the local communities are not entirely in favor of that. And many of the environmental protection agencies are also very negative about these things. So here, there is some big problems to be solved in the future. So before we go into food and drink, I guess we're going to have a short break. I would say let's have a short break of 10 minutes, and I'd like to welcome you back at about 11:10. Thank you for your attention, and I'm going to grab myself a cup of coffee as well. Thanks a million.